before we start a study of trig, it's first important that we know a couple things about Pythagorean theorem and radicals, specifically rationalizing numerator and denominator. So Pythagorean theorem, remember, is a squared plus b squared equals c squared. We're going to use that a lot as we use right triangles all the time. And the radicals we will discuss here in a second. So if I look at a Pythagorean theorem example, it's tough to say. I'm going to start with a right triangle. I know it's a right triangle because I say so. And I'm going to say that this is 6, this is 10, and I want to find the missing side, which is this guy up here. So I start out with this a squared plus b squared equals c squared. I have to remember that the side opposite the right angle is going to be my c value, my hypotenuse, every single time. So these other two legs, I can label them a and b. It doesn't matter which one I call which. So when I go to put it into my formula, I get 6 squared plus 10 squared equals c squared. So I end up with 36 plus 100 is c squared, or 136 equals c squared. So in order to undo the squared, I apply square root to both sides. I don't put the plus or minus because I only want the positive in this case. So I get the square root of 136 equals c. Now I can't just leave it as the square root of 136. I have to check if that factors down at all. So I take the 136, I divide it by 2 and start my factor tree. So that's going to go into 13 6 times, and it's going to leave me with 68. And then 68 becomes another 2, and I get a 34, and 34 is 2 and 17. So this is really the square root of 2 times 2 times 2 times 17. If you remember from Algebra 1, I'm allowed to take a pair and pull it out. So this becomes a 2 outside. The 34 is going to stay inside, and that equals c. So the side length, the hypotenuse here, is 2 root 34. And we have to make sure that we reduce those square roots, if at all possible. For example 2, we're going to have a slightly different orientation for our triangle. So if there's my right triangle, just so we can mix it up a little bit, I'm going to be told that the hypotenuse is 6 root 10. I know that this other leg is 3. So I'm trying to find this missing value. So if I think about this in terms of A, B, and C, I'm given C, I'm given, let's call it A, and I need to find B. Doesn't matter which letter I use. So I start with Pythagorean theorem, fill in what I know. That's going to be 3 squared plus the unknown squared equals 6 root 10 squared. Obviously a 9 on the left-hand side and a b squared. Now I have to know that when I go through and multiply 6 root 10 by itself, it's like I'm distributing the squared back to each of my pieces. So I get a 6 squared, which is 36, and a 10 squared, or a 10 root 10 squared, which is 10. So I have 9 plus b squared equals 360. I go to solve for b squared. That's going to be 351. And apply the square root, I get b equals the square root of 351. Now I'm still going to go back and think about it. 351, if I go ahead and bring them down some, that gives me 9 and 39, if you check it out. And from there, I can't really go any further. I mean, that's obviously 3 and 3, and 39 is 3 and 13, but that doesn't help me much when I'm trying to simplify. So the square root of 351 is 3 times 3 times 3 times 13. Or I could rewrite it by pulling out the pair as b equals 3 root 39. That's my missing b value. The other skill that I should be proficient at whenever I'm starting out this unit is what's called rationalizing a denominator. Hopefully something you saw in Algebra 2. Rationalizing just means no square root in the denominator. So we have to go through and get rid of any square roots that happen to show up. Not a difficult process, but a process we're going to follow a couple times as we go through trigonometry. So I have 1 divided by root 2. Again, my rule is no square root in the denominator. So I have to rationalize, which means I multiply the top and bottom by something to get rid of the root 2. In this case, I'm going to multiply by root 2 over root 2. Because up top, I get the root 2, that's fine. And on the bottom, root 2 times root 2 is just 2. So when I rationalize 1 over root 2, I get root 2 over 2. No square root in the denominator. If I had a second example quickly, I have a 7 over 5 root 3. The 5 is okay in the denominator, it's the root 3 that I have to get rid of. So I'm going to multiply by root 3 and root 3. So I get 7 root 3 over, well, root 3 times root 3 is 3. So I have 5 times 3, or 15. So that is my rationalized answer. So rationalized is no square root in the denominator. And as I scroll up, Pythagorean theorem, just make sure that we can apply that whenever my side lengths have square roots in them.